Group 8, Carson Stermer, Eric Vazquez, Sal Luzzi, and Ryan Girardini.
Our primary goal of our filter was to have a cheap and fast filter that had a clean look to it. We wanted to build a filter that would be easily reproduced because when we were first introduced to this project, we were told that we were a company being tasked with building a filter. From a company's point of view, we wanted to build a filter that would work decently well and was cheap so that it would be produced more readily. Another aspect we wanted to approach in our design was making sure that it didn't look like a complete mess and was thrown together last minute. We wanted a filter that had a clean look to it and that would be appealing to an audience.
During our experimental testing, our filter looked like a filter that could be competitive in the overall class. When we did our experimental testing, we conducted it very similarly to Homework 3, and that was that we ran different dilutions through the filter for the purpose of being able to compare the values collected to the calibration curve we created. When testing standard dirty water through our filter, we end with the absorbance value of 0.059, which means that our filter was able to remove 94% of the dye that was put through the filter. At 1/2 dilution and the concentration of 1/2, our filter water gave us an absorbance value of 0.037, and this trend continues to decrease as the dilution of the water becomes smaller. Our filter, however, did not work as well as predicted during the actual testing when our water was returned with an absorbance value of 0.9736, which is very poorly and means that less than 3% of the dye was removed compared to 94% removed during our experimental tests.
Our device looked as followed. It consisted of 7 different materials: a pipe, end-capped, coarse sand, fine sand, activated charcoal, filter paper, rubber bands, wooden dowels. Our price came to a total of $123.36. Our filter weighed 148 grams and had a very large volume of 1,943.76 cubic centimeters. If I could give an analogy for what our filter looked like, ours looked like the UConn water tower with a scaffolding wrapped around it. This is because our main filter is just a 6-inch long, 1-inch pipe with an end cap. However, we used wooden dowels and rubber bands to create a platform that wraps around the device that allowed our filter to be easily placed on top of a plastic cup and allowed for easy mobility. Without the wooden dowel stand, our device's volume was 250 centimeters cubed. The layer of our filter at the bottom was an end cap with 5 holes in the shape of a plus sign drilled in the bottom of the end cap. We then had filter paper layer over the holes to stop the media from escaping the device. Above that, we used coarse sand, activated charcoal, and then topped it off with some fine sand.
This is the graph of the calibration curve. These are our Arduino data results. Our official final results are shown under Group 8 compared to the rest of the class.
When we were designing our filter, we decided to go with a pipe and an end cap. Therefore, we ran into the problem of how to get the water out of the filter because it was completely sealed and capped at the end that the water needed to come out. We decided to go and drill a hole into the end cap to allow water to drain out of the filter, and then ran into a new problem of how to stop the media from leaving out the hole of the end cap. We solved that problem by placing a cotton ball at the bottom of the filter to stop the media and filter the water. However, when we ran the water through it, the cotton ball sucked up all the water instead. This led to our final design of the project, which we ditched the cotton ball and replaced it with a filter, and also added 4 more holes to the bottom of the filter to allow for even more water to flow out. If we had more time, we would have liked to run more tests to account for the error that had occurred because our experimental test went much better than the final test. At testing day, we ran into the problem that activated charcoal ended up dyeing the water that we were filtering, and in the end made the water almost darker than when it was originally entered. When we first ran experimental tests, we did not have this problem, so we were not aware that this was a possible problem when running our filter. Therefore, when we went for a final test, we discarded all the old material in our filter and started with fresh material because that we didn't run any water solution through it, and it returned would have gotten rid of all the black residue present on the charcoal. We just tested with the new material and our water was dyed. With more time, we would have liked to done more trials and more quality trials in hopes that we could have found the charcoal problem ahead of time and found a solution for it.